We'll say polyprotic acid. Often acid molecules have more than one ionizable H ion. These are called polyprotic acid. For example, H2SO4, H3PO4, etc. If only one hydrogen monoprotic, two hydrogen diprotic, three hydrogen triprotic. For example, for monoprotic HCl, diprotic H2SO4, triprotic H3PO4, phosphoric acid. So polyprotic acid ionize in steps. It is not like monobasic acid or monoprotic acid. It will ionize in several steps. So each ionizable hydrogen removes sequentially. First one hydrogen, then second hydrogen, then third hydrogen. So in the case of H2SO4, it's contained two acids. So it will ionize in two steps. First it remove one hydrogen. Second step it hydrogen, the second hydrogen. So we'll see factors affecting acid strength. So the factors affecting acid strength are extent of dissociation of an acid depends on the strength and polarity of HA bond. That is hydrogen and acid bond. Hydrogen and another substance will be there like HCl, hydrogen and chlorine. So hydrogen and chlorine bond or hydrogen and another conjugate substance bond. The strength. Then strength of HA bond decreases as the energy required to break the bond decreases. If HA bond strength is less, then we can easily break that bond. That is, HA becomes a stronger acid. So it is a strong acid. If HA bond is weak, it is a strong acid. Then HA will be stronger. For example, if you take HCl, HCl, HF, etc. Here hydrogen is very small, fluorine is very fluorine also very small, and is a very electronegative difference between hydrogen and fluorine. So the bond, the more electron towards will be in fluorine. So what there is bond energy is very less, so it can break easily. So HF is a very strong acid. So this bond we can easily break. So HF, HCl, HBr and HC, this is the order. As size increases, the acid become strong. We can see here the acid strength increases in this order. We know hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide. In the case of this, hydrogen iodide is the most strongest one because as size increases, the acid strength increases. Then electronegativity of central atom increases. If the electronegativity of central atom increases, acid strength increases. Then general trends in acidity. The stronger an acid is donating H plus, the weaker the conjugate base is acid H plus. That we have already said. If you take an acid, if you dissociate, the stronger acid donating H plus easily, the weaker conjugate, the base will be the conjugate base weaker. If a strong acid, the conjugate one will be weak base. So it is H plus. So higher the oxidation number of an acid, stronger is the its oxy acid. For example, here it is the order H2SO4, H2SO3, HNO3, HNO2. Cations are stronger than acid than neutral molecule, and neutral acids are stronger than anions. This is the order. Cationic acid have more strength than neutral than base. So if you take here H3 plus is cation which carrying positive charge, it is more stronger compared to neutral water than basic water. Ammonia example also there. Bases having an opposite trend. Then common ion effect. For reducing the concentration of hydrogen ion is called the common ion effect. It can be defined as the shift of the equilibrium on adding a substance that provides more of an ionic species already present in the dissociation equilibrium. That is, common ion effect is based on the Le Chatelet principle. Hydrolysis of salts and the pH of their solution. Salts are formed by the reaction between acid and bases. We know this one is neutralization reaction. So the cations and anions formed, if these salts dissolved in water, there will be ionization occurs. Cations and anions. It will split into cations and anions due to the ionization of salt. Either maybe it is exist as hydrated ions in aqueous solution or interact with water reform corresponding acids and bases. The later process interaction between water and cations or anions or both the salt is called hydrolysis. We know this process is known as the interaction between water, cations, anions, salt is known as hydrolysis. The dissolution of salt in the water is known as hydrolysis. The degree of hydrolysis is independent of concentration of solution, and pH of the solution determined by the pK value. So the pH, we know the pH of the solution. Using the pH, we can identify whether it is acid, base or salt. If pH is equal to 7, the solution will be neutral. And pH we can calculate by the formula 7 plus half pKa minus pKb. The next one is buffer solution. The solution which resists the change in pH on dilution or with the adding of small amount of acid or alkali are called buffer solution. If we take some solution, if we add small amount of acid or base, it will not change its pH. It having a constant pH. Such solutions are known as buffer solution. The solubility thing is deleted. This is all about this chapter. We will solve the problems in next class. Thank you.